is, okay, it's going to be something like this. Till you get to first success. Fail, 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 dot, 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 fail, and then a success. All right, so F, 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 dot, 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 F, and then a success. Okay, so we don't know how many, well, altogether there are N trials, right? You have N trials. We want a success on this last one, so that means how many of these Fs do we have? N minus 1, right? Like if there was 5 trials, we would need 4 failures, then a success. So what we're going to have for our distribution is I'm going to write it this way. 1 minus 0.62 is 0.38. I'm going to write it as 0.38 raised to the N minus 1 and then times the 0.62. Now, I suppose you could write it like this. It's multiplication, so the order doesn't matter. Maybe you could write it like this. 0.62 times 0.38 to the N minus 1. Same thing. Part B, what's the probability that Susan passes on the first try? All right, so on the first try, what she needs is a success, right? And the probability of success is 0.62. Part C, what's the probability that she first passes it on the second try? So what she needs is a fail, then a success, right? A fail and a success. So we got a 0.38 and then times a 0.62. Now I got 0.2356 and we're supposed to round to 3 decimal places. So 1, 2, 3, that's a 6. I'm going to round up 0.236. Now part D says, what is the probability Susan needs more than 3 tries to pass? All right, more than 3. So I'm going to write it down here. I wrote it in English. More than 3, 3 or more. Now 3 or more, expand it out. Get a good feel for what it is. 3 or more, 3 or 4 or 5. I mean, you could keep going. We don't know where to end. So when you see things like this, think opposite. You think opposite. And as soon as you say think opposite, it's a 1 minus, okay, 1 minus, all right, now what is the opposite of 3, 4, 5? Okay, well, all right, I'll ask you this. Could you have a 0? Could it be a 0 or 1 or 2? All right, well, what are these numbers in here? These are the number of trials to pass, number of times you take the test. It can't be a 0, right? You have to at least take the test 1 time. All right, so we can toss this one out. So what's the probability that it's 1 or 2? So 1 minus the probability of a 1 or a 2. So we could write this as 1 minus, okay, it would be this, the probability passing on the first plus the passing of the second, right? It's an addition. They're mutually exclusive. If you pass it once, you're not going to pass it again because you won't take it again. So what I'm going to do here is say 1 minus the probability of passing on the first try minus passing on the second try. So it's going to be 1 minus, okay, what are we going to get here? Passing on the first try was what? Oh, that's why they gave us that problem. Passing on the first try was 0.62. Passing on the second try, we just found that, 0.236. That's why they gave us parts A and B. And I got 0.144 to 3 decimal places, so I'm going to say that's 0.144. And the last part, E, says what is the expected number of attempts? This is a geometric. So for geometric, we have this. All right, I need to get writing here. All right, so for a geometric distribution, the mean, that's the expected number, is 1 over P. So in our case, all right, this is the expected number. It's the mean, that's always your expected number. So for us, it's going to be 1 over point, what do we have here, 6762. All right, so 1 divided by 0.62 gives me 1.6129 dot, 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 says 2 decimal places. So 1, 2, how about 1.61? I'll go with that one. So it should take her about 1.61, which of course you can't get a 1.61, but let's talk about it. If you averaged everybody that took this test, everybody in college that takes this Western Civ class, and you average out you count how many times it takes people to pass. If you take an average, right? Some people will take 1 time, some people 2, sometimes 3, but on the average, 1.61.